Top 10 rarest gems found underground, hidden beneath volcanic tombs, sealed inside folds of ancient bedrock, and formed under conditions so specific they border on geological coincidence. These gems weren't shaped for beauty. They were buried in silence beneath pressure, heat, and time. For decades, their existence was debated. Some were mistaken for lesser minerals. Others went unnoticed for generations. And yet today, just a few carats of these underground relics can command fortunes, not because of their sparkle, but because of their scarcity. This is the story of the 10 rarest gems ever pulled from beneath the surface. And the one at the top? It changed the very definition of rarity. Don't forget to press and hold that like button, leave a comment, and hit subscribe before we begin. Ranked 10th, Black Opal, fire buried beneath the outback. Hidden deep beneath Lightning Ridge, Australia's sun-baked claystone, lies a gemstone that defies logic and light. Black Opal. Unlike common opals found in surface layers, black opals are born in narrow seams of Cretaceous volcanic ash, often over 30 feet underground, in cavities left by ancient, mineral-rich waters. Under immense pressure, silence, and time, nature writes color into stone here. What makes it one of the rarest underground gems on Earth? Simple. Authentic black opal must possess a pitch-dark body tone, acting like a stage that explodes with neon reds, electric blues, and flashing greens when light hits just right. Less than 0.1% of all opals ever mined meet this standard. Most are found only in a single square mile of Earth. High-grade black opal can command $10,000 to over $100,000 per carat, depending on the pattern, color saturation, and contrast. One historic piece, the Aurora Australis, sold for over $700,000, weighing just 180 carats, less than 2 inches across. But its value isn't just monetary. Black opal is Earth's emotional paradox, a gemstone forged in darkness that bursts with the spectrum of light. Every polished piece holds a storm, a fire, a story, carved from the underground shadows of an ancient land. No other gem captures both depth and fire so literally. That's why black opal doesn't just shimmer, it haunts. Ranked 9th, Paraíba Tourmaline, neon fire pulled from the deep earth. In the mineral-rich hills of northeastern Brazil, a shaft less than 10 inches wide once revealed a new spectrum to the gemstone world. The year was 1989. From nearly 100 feet underground, miners unearthed a crystal unlike anything documented, glowing with an electric blue that looked charged from within. It was soon named Paraíba Tourmaline, after the Brazilian state where it was found. This gem owes its shocking coloration to trace elements of copper and manganese, an elemental pairing rarely found in tourmaline. But the color alone isn't what grants it a rarity. It's the geological improbability of its formation. These tourmalines grew slowly in isolated pegmatites, trapped inside narrow quartz veins that cooled over millions of years. Only in a few deep fractures did the right balance of chemistry, pressure, and time converge. High-quality Paraíba specimens weigh an average of under 5 carats, yet command prices that rival precious stones 5 times their size. Top-tier material, especially with vivid saturation and minimal inclusions, can exceed $50,000 per carat. Even among seasoned gem dealers, finding more than a few top-grade stones annually is exceptional. The original Brazilian mines have mostly been exhausted. Today, only limited deposits in Mozambique and Nigeria produce stones of similar chemistry, but none carry the mystique of the ones dug from beneath the dusty hills of Paraíba. Its origin story begins in darkness, but ends in pure electric color. Ranked 8th, Alexandrite, the hidden shift beneath imperial soil. In the early 1830s, deep beneath Russia's Ural Mountains, miners searching for emeralds uncovered an anomaly, crystals that glowed green beneath the sun, yet turned wine red by flame. What emerged wasn't a variant of Beryl, but an entirely different mineral. Alexandrite, later named for the heir to the Russian throne. This gem forms within narrow geological fault zones, pegmatite intrusions rich in beryllium, penetrated by chromium-bearing fluids. These intersecting conditions must occur tens of meters below ground, making each formation rare and geochemically improbable. This microscopic interference of light through chromium creates a dramatic color shift, a distinct transformation that has become the gem's identity. Stones with an intense, balanced change from bluish-green to purplish-red are incredibly scarce. Most measure under 1 carat, and clean, vivid material over 5 carats routinely enters the six-figure range. While new deposits in Sri Lanka and Brazil have contributed to the market, the original Russian finds remain benchmarks, relics of geology and imperial ambition. Alexandrite doesn't dazzle through brilliance or size. Its power lies in duality, a structure that holds opposing colors in a delicate equilibrium. Buried beneath centuries of soil and empire, it reflects the Earth's quiet ability to shift, adapt, and astonish, all within a single stone. Ranked 7th, Taaffeite, the mistaken rarity buried in plain sight. Before it was recognized, it was overlooked. Taaffeite entered history not from a mine but a jeweler's discard tray in Dublin, Ireland in 1945. A spinel, so it seemed. But under polarized light, the gem refused to behave. What had been thought common revealed a different crystalline structure and a new mineral altogether. Its story begins much deeper. Taaffeite forms within metamorphosed limestone and mineral environments, saturated with beryllium, aluminum, and trace elements like magnesium, a volatile chemical cocktail. These conditions occur only in select pockets beneath the Earth's crust, often in Sri Lanka and southern Tanzania, where tectonic pressure and heat forge the mineral in subterranean veins several dozen feet underground. True gem-quality taaffeite is rarely cut. Most finds are opaque or fractured, unsuitable for faceting. Stones over 2 carats are exceptional. High transparency material with strong lilac or mauve hues can reach $15,000 per carat. Not because the gem dazzles, but because few clean crystals exist. Unlike stones that announce themselves in explosions of color or fire, Taaffeite whispers, its rarity isn't in spectacle, but in error. For decades it passed unnoticed, misidentified as something lesser, hiding its worth in plain sight. Few minerals remind us how little we see, even when looking directly. Fewer still are buried not only beneath the earth, but beneath assumption. Ranked 6th, Jeremejevite, the blueprint crystal lost in stone. On the frigid edge of the Namib Desert, in a deposit carved into the base of Mount Orongo, miners have pulled from the rock a crystal so structurally perfect it looks like a prototype. Jeremejevite. Long and prismatic, often colorless or icy blue, its form resembles a computer rendering brought into reality. The rarity begins at the molecular level. Jeremejevite is an aluminum borat fluoride that requires specific pressure, mineral saturation, and slow crystallization within granite pegmatites buried over 100 feet beneath the Earth's surface. These pegmatites, hardened magma tubes cooled over tens of millions of years, are where nature archives its most complex geometries. Most Jeremejevite crystals are slivers. Full-length face-stable specimens with minimal inclusions are nearly never found. The finest examples under 2 carats can command up to $15,000 per carat, not for brilliance, but for geometric purity. Namibia has produced the most notable material, though isolated samples have surfaced in Myanmar and Tajikistan, each with its internal fingerprint. While other gems are admired for fire or color, Jeremejevite earns reverence through restraint. It does not shout for attention. It doesn't need to. Its presence suggests an underground, mathematical, exact system that only reveals itself when the Earth is ready to part. It is a gemstone that is less discovered than decoded. Ranked 5th, Grandidierite, the blue-green light beneath forgotten shores. Near the windswept coastline of southern Madagascar, beneath a crust of metamorphosed rock shaped by tectonic collisions, lies a gem whose hue defies easy definition. Grandidierite, neither fully blue nor entirely green, carries the tone of seawater seen through glacial glass. And just like its color, its location is elusive. This mineral forms under high pressure in pegmatitic aluminous rocks, often embedded in quartz veins tens of meters deep. It emerges not in clusters, but as solitary crystals, shielded by layers of ancient bedrock. While discovered in 1902, cuttable material remained largely theoretical for over a century. Most specimens were opaque, fractured, or far too small to be of value. Then came a find in the cliffs outside Tranamaro. Crystals deep within the altered bedrock yielded a handful of faceable stones, most under 1 carat, some just a few millimeters across. Exceptional transparent specimens with strong pleochroism, color shift from blue to green, have sold for up to $20,000 per carat. Fewer than 1,000 carats of gem-quality Grandidierite have entered the market. Beyond rarity, its visual signature is unmistakable. Grandidierite does not glow. It pulses, refracting internal color like light filtered through mineral-rich tides. Few stones carry so much presence in so small a form. It is not a stone that announces its value. It's a stone the earth tucked away, as if saving it for someone patient enough to look twice. Ranked fourth, Serendibite, the midnight core of the earth's oldest stone. Some minerals sparkle, then some minerals seem to absorb light, pulling it inward like a collapsed star. Serendibite belongs to the latter, in only 2 primary locations on Earth, Sri Lanka and southern Myanmar. This gemstone forms within skarn deposits, a product of magma forcing its way into calcium-rich rock. The result is a mineralogical battleground, where heat, pressure, and chemistry converge in pockets often buried up to 100 feet underground. Most serendibite is opaque and black, sometimes displaying hints of green or blue under intense illumination. But in sporadic cases, deep underground fissures yield gem-grade material that, when cut, reveals a near-metallic luster, almost obsidian in body but layered with subtle shifts in tone. Stones over 1 carat are nearly unheard of. Fewer than 30 faceted specimens exist globally. When one crosses the auction block, price tags start near $18,000 per carat, climbing sharply with size and translucency. No new significant deposits have been discovered in decades, and most known sources remain small, remote, and geologically unstable to mine. Serendibite carries silence. No folklore surrounds it, no empires rose for it. It exists outside the narrative, a dark matter of the gemstone world, known to only a few, sought by even fewer. What it offers isn't brilliance, it offers gravity. Ranked third, Red Beryl, the crimson vein of the Rocky West. Beneath the remote volcanic mountains of southwestern Utah, the earth carries a red that most people will never see. Not ruby, not garnet, something far rarer. Red Beryl, sometimes called bixbite, grows in narrow fractures within topaz-bearing rhyolite, a volcanic rock formed over 20 million years ago. Its creation demands extremes: high temperature, low pressure, and a precise infusion of beryllium and manganese delivered through superheated gas pockets deep underground. Red Beryl is found in only one commercial source, the Wawa Mountains. Mining here is more like surgery than excavation. Crystals form in hairline cavities, often less than an inch across, buried within rocks so brittle that blasting risks destroying everything. The scale of its rarity is difficult to overstate. For every 150,000 diamonds mined worldwide, only 1 Red Beryl is found. Most weigh under 1 carat, and clean, well-colored specimens above 2 carats are geological marvels. Top-grade stones have fetched $50,000 per carat, though many never leave private collections. But price isn't what defines it. Red Beryl is one of nature's smallest rebellions, an impossible shade coaxed from violent heat and barren stone. There is no grand mine tour, no polished boutique pipeline. It waits beneath ancient lava fields where silence and patience shape color into a rarity. And when found, it doesn't shout. It simply endures, quiet, exact, and undeniably real. Ranked second, Musgravite, pressure written in stone. It began with a misclassification. In 1967, geologists surveying the Musgrave Ranges of Central Australia catalogued a translucent, smoky purple crystal as a variety of Taaffeite. It wasn't. Under further analysis, they discovered an entirely separate mineral, structurally distinct, chemically complex, and unimaginably rare. They named it Musgravite after the mountain chain that first revealed it. The crystal forms deep within ultramafic metamorphic rocks, where high-pressure magnesium silicates collide with trace elements like beryllium and zinc. These conditions are only found in fractured zones of Earth's lower crust, often over 100 feet below the surface. Growth is slow, molecularly patient, usually stretching across millions of years within a geologic environment so specific it has produced only a handful of faceable gems worldwide. The rarity isn't in legend but in mathematics. By the early 2000s, fewer than 20 confirmed gem-quality stones were known. Each weighs under 5 carats, most under 2. When available, they command values from $35,000 to over $50,000 per carat, depending on clarity and color. Smoky gray, olive green, or violet under mixed light. Musgravite lacks the vibrant flame of opal or the optical trickery of Alexandrite. What it offers instead is compression, evidence of time layered into structure. There is no glimmer meant to dazzle from across a room. Its brilliance is found in stillness, in order, in deep crystallographic symmetry. Some gemstones dazzle, others remind you where they came from. In the first place, Painite, the name that once meant one. When Arthur C.D. Payne first uncovered a reddish-brown crystal in Myanmar during the 1950s, it was catalogued, measured, and shelved, unremarkable until someone tried to classify it. What followed was decades of silence. No matching specimen appeared in Burma, Ceylon, or any private or museum collection. For nearly 50 years, Painite stood alone, the only gemstone on Earth. It forms deep within boron-enriched pegmatites, where rare earth elements like zirconium and vanadium are squeezed under immense pressure, typically at depths exceeding 100 feet. The geological cocktail required to create Painite is so precise that it was once thought to occur only once. Even after renewed exploration in Myanmar's Mogok region, faceable crystals remain almost mythic, often locked inside corundum-bearing marble and resistant to extraction. Today, only a few hundred stones exist in cut form. Most are under 3 carats. Transparent material over 5 carats is so rare that its price, often $50,000 to $60,000 per carat, becomes secondary to its existence. The finest examples show internal flashes of amber, garnet, and ember tones, colors that feel ancient as if lit from a furnace long extinguished. Painite isn't just rare by quantity, it's rare by category. It sits at the edge of classification, where chemistry, mineralogy, and time intersect so briefly that the outcome feels accidental. This is not a gem that changed markets. It changed definitions. They were never meant to dazzle in shop windows. They were forged in silence, born from pressure, chemistry, and time. Long before the first tools, words, or eyes that would one day recognize their worth. These aren't just gemstones. They're geological survivors. Each one is a fingerprint from the Earth's most guarded vaults. No marketing could invent them. No machine could repeat them. What they offer isn't abundance, it's an exception. They were waiting to be understood. And now that they've surfaced, they tell a deeper story. Not just about minerals, but the planet itself. Let us know which resonates with you in the comments, and don't forget to like and subscribe to our channel for more content like this.